I am on page 74 of the textbook, and we're looking at example 6. This is an example of compound probability using independent events. When flipping a penny twice, what is the probability of getting 2 heads in a row? All right, let me just make a copy of this. We're going to pretend that this is our penny. So let's bring it down here. So what they're asking me is, what is the probability of getting this? Two in a row. So the first one is heads and the second one is heads. Well, the probability here of getting heads is 1 out of 2, or 50%. The probability of getting heads on this one is 1 out of 2, or 50%. So we want to know the probability of this happening in a row. So and means multiply. 1/2 times 1/2 is 1/4, which is 25 hundredths, which is 25%. Would you bet on that? I don't think I would. Okay. This is called independent events because the first and second flips of the coins are not related. The second one does not depend on the first one in any way. Here's another example of that. Here's a bag of marbles. Pretend that's a bag. All right. In this bag of marbles, there are let me count the one in the book, because if you're following the book, you'll need 1, 2, 3, it looks like 6 white marbles. And I'm going to make a copy of those 2. Excuse me, those 3. And copy them in here. Mine are not arranged quite the same as theirs, but bear with me here. And then we have 3 more. Let's cram in there. There's 1, 2. So here are some marbles in a bag. That's pitiful. Okay, there are 3 gray marbles, or I'm going to make mine black because I don't want to have to go hunt a gray pen, but we'll just call them black and white. And again, mine are not arranged the way theirs are, but they should match number-wise. So here are marbles in the bag. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, okay. So this is proportionate. It just doesn't look like theirs. So what is the question here? What is the probability? Okay. I want to know the probability of drawing a white marble and a white marble. Now, this is not their example. I'm making this up. And a white marble if you replace the marble each time. So you draw a marble out, you see what color it is, and then you put it back in the bag. Well, probability of white is 6 out of 9. You put it back in the bag. 6 out of 9. Put it back in the bag. 6 out of 9. Question is, would you bet on this? Would you take a chance that this is going to work? So 6 times 6 times 6 on top is 216. And then 9 times 9 times 9 is 729. Let's reduce that. So 216 fraction 729 equals 8 over 27. So there's an 8 in 27 chance. Is that close to 0 or close to 1? So in other words, on this probability line, where would that 8/27ths be? Is it impossible or is it 100% certain? Well, let's do the decimal. So 8 divided by 27 is 0.296 and some junk. So let's call it about 30%. So it's about right here on the line. 8/27ths, it's less than half. So you would have a probability about right there of this happening. I personally would not bet on it. But I don't bet on anything if it's not 100%. This is 30%. This is 0%, impossible. And this is 100% certain. So the complement of 30% would be 70% against you. So it would be a gamble for sure. All right, let's look at the calculator skill, and then I am going to stop the video before I do dependent probability because I want to make a break there. But over on the left margin, I normally don't do these because they deal with the TI calculator, but I can show you the Casio steps to do this. Here's the story. Remember that when calculating the probability of independent events, the probability of each independent event is multiplied. If the independent events have equal probabilities, then instead of multiplying all of the probabilities, you can raise the probability to the power of how many events there are. Try the following using the fraction button and the exponent key. So number 1 says to find the probability of flipping a coin 20 times and getting a tails every time. So here is the coin. Oh, I thought I had my penny still up here. Let me delete that and get the penny. So here's the penny. A picture always helped me. I hope it helps you. So here's the penny. What is the probability of getting tails? Well, it's 1 out of 2. That's for one independent flip. So if you want to do that 20 times, you can multiply 1/20th times 1/20th times 1 half times 1 half times 1 half times 1 half times 1 half. That was just 5 of them. We have to get to 20 of them. So a much faster way on the calculator is to take the 1 half and raise it to the 20th power instead of having to write all that out. So here's how you would do that on the Casio. And remember, when I do calculator buttons, I always want to draw those so it doesn't get mixed up in my problem. I think I'll have room. I didn't think this through, so because this one's a fraction. You could put it in as 0.5 to the 20th power, but either way, it'll work. So first thing you want to do always is all clear. And you put in 1, ABC, this is the fraction key, 2. Then the exponent key is the XY. This is called the fraction key. This is called the exponent key. The exponent key is above the yellow C, or whatever, on mine it's yellow, the clear key. If you look for XY. And then you put in the 20. That's your exponent. And the last thing you should hit is equals. So would you bet on this? Would you bet $100 that you could do this? Flip the coin 20 times and it turn up tails. So all clear, 1 fraction 2 exponent 20 is, wow. Is that right? Let me try that again. Yeah, that's right. And no, I wouldn't bet on it. So here's what we get on the Casio. 9.5, 3, 6, 7, 4, 3, 1, 6, 4 to the negative 07. That is scientific notation. And I'm going to have to do a little bit of adjustment here. I'm running out of room. So let me bring this up here. I'm going to have to resize it to get it to fit. And then I'll show you how to read that big ugly number. So what this means, this minus 07, let's go ahead and draw 7 blanks. 1, 2, 3, 4, 5, 6, 7. And in the last one, I'm going to put the number 9. Okay. This minus means that we're dealing with a decimal. So we're going to put our decimal out here. And we have to fill this with zeros. And then we have 5, 3, 6, 7, 4, 3, 1, 6, 4. This is an ugly, ugly number. But this is what you would read this if you're just looking at the underlined places. You have 9 tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, millionths, 10 million. So you have 9 10 millionths of a chance of this happening. Would you bet on it? No way, I wouldn't. If you look at that as a fraction, it's going to be 9 over 10 million. Not very good odds. Okay, one more of those. We have number 2 there. Find the probability of a basketball player who has a 70% probability of making a free throw, making his next 7 free throws. So the probability of making a free throw is 70%. Okay. As a decimal, that's going to be 0.7 or 0.70. You could do it that way. And we want to know what the likelihood is that he's going to make his next 7 free throws. So we could say, here's the first one, the second one, the third one, the fourth one, the fifth one, the sixth one, and the seventh one. Now you can type all that in your calculator, but it's much quicker to say 0.70 to the 7th power. And let me just copy my calculator buttons instead of drawing all that again. And we'll try this one on the Casio. Okay, the buttons haven't changed. Actually, they have changed because we're not using a fraction key this time. You could, the fraction would be 7/10, so you absolutely could use it. But I'm going to just put in 0.70 and the exponent key to the 7th power. And you can even type it out like we did. We wrote it out up there. That's fine. Equals 0.08235543. But there's no scientific notation this time. So this is going to be about 8%. A little bit better odds on that one than number 1 there. I still wouldn't bet on it, but I'm not a gambler. So, alrighty. I do want to check these. Let me just be sure while I have you here, because if I don't, I have to go back and amend the video, and it's just a lot easier for me to check them while you're with me. Page 74 in the margin. 8%. Okay, they call this 8.2%. That's fine. It just depends on where you round it. And then they did, let me count my zeros here. They did 1, 2, 3, 4, 5, 6, and then 9, 5. So they went one more step. I called it 0.00009. They included the 5, but that's okay. Either way is fine. So those are correct. The point they're trying to make there is to use the exponent key instead of writing out that long problem. I'm going to stop this video, and then we will look at dependent events in the next video.